Andy's department, and that's where the station is working on. That gives us a backup dispatch center now, doesn't it?
It does. So basically the older dispatch centers would be the backup dispatch centers in case something happens and we have to revert back over to the old dispatch centers.
Sounds like a pretty good improvement.
Yeah, it's a nice big building, that's for sure.
Thank you. All right, do we have any other announcements that anybody would like to make? Sure, talking about field day.
Hey, William,
Yes, sir.
I just want to recognize we got some online people that have joined us. We got Joe Tabra from H6T from Oahu. Joe, you want to say hello? You're muted. Do we have the sound on?
Should. Oh, I closed the meeting and went back in. Hold on a second. Yeah.
I just unmuted it.
Well, I may not actually be on the right audio source still.
We may be having audio difficulties, Joe, so stand by a second.
So that's there, and
H6T, can you give us a free count? Nope, we're still not getting it.
yeah, I think we're good on our end.
Not sure why. Lee, do you want to go ahead and say hello? I'll unmute you.
Hello, WH6LC, Mountain View, back to you.
Thank you. We got you, Lee. We could hear your audio. All right, Joe. Well, apparently the audio issue's on your end, so we'll just say hello. And we've also got Alan. Alan, you want to say hello? Introduce yourself.
Hello, everybody. Alan McBride, KB0 VKF from the mainland. I've been here a little over a year now.
All right, and we've got, thank you, Alan. We've got one more, Alan. You want to say hello and introduce yourself?
Very good. I'm Alan, Alpha Delta 6 Echo / King Henry 6 Tango United, your local Pacific section manager. Yeah, thanks for inviting me in. I just wanted to kind of sit back and hear what's going on. You're talking about field day coming up. Please make sure that your club gets registered with the ARRL so that other people who may not understand or may not know about your field days can find you.
Thanks, Alan. So just to let everyone know, William and I were going through all of the technology to basically be able to host these hybrid meetings while also having an audio solution so that we can amplify the people here so that everybody can hear everybody.
But then also amplify the speaker up here. So if it's not like me or Roy up here where we've got, big set of pipes, but everybody in the room can hear them too.
Yeah, it's actually a lot more complicated than you would think to do the noise cancellation with a hybrid meeting, have a PA, to have remote wireless mics. That's what we're trying to put together here. And I think we've got a pretty good solution in play. And the board has already approved this. So we're going to be making an expenditure hopefully in the next 30 to 60 days to get our audio set up to par. Back to you, Wayne.
All right. So like I said, are there any other announcements that anyone would like to make the meeting before we start talking about the full days? All right. Let me go ahead and get my first presentation up.
While he's doing that, I'd just like to thank Bill Hansen at Civil Defense, the Auxiliary Communication Service, for hosting this summit coming up on Thursday. And I hope we can all make it, many of us as possible. We take our direction from him and the county when it comes to how we can help out during an emergency. That partnership is absolutely key. We have a memorandum of agreement between the club, Big Island Amateur Radio Club and Civil Defense. We try to work together, and we're hopefully going to be able to hammer out some details on how to work together. I would also mention that every year, the Amateur Radio Emergency Service has participated in Makani Pahili kind of as our own separate organization, because we want to give people the opportunity to practice using the radio as if it were a simulated emergency. So we are doing that this Saturday from 9 to noon. But it's our ideal that we could combine these efforts with civil defense. We do need a kind of a separate training because we get new operators all the time that are just coming to speed. But once people are fairly proficient at using their radios and transmitting via voice, recording and writing down everything they transmit, that's the time when exercises together with civil defense is really, really important so that we can help them during an emergency. It happens frequently, just about every year. We get an event where we lose power, sometimes island-wide, sometimes just isolated areas, but it does happen frequently. And maintaining that communication pathway in an emergency is something we really do need to practice and focus. So thanks again, Bill.
Well, practice and focus, that brings us to field day. Who here's attended a field day before? All right, that was my way of not singling out the people who haven't attended a field day before. There were a couple of hands that didn't go up. I'm sure everybody knows all about the original field day, right? We were all here for it.
So field day is an ARRL. Darn it. There we go. Is an ARRL event, the American Radio Relay League. They've been around quite a while. There's only a few members that were around before that got started. And so field day is sort of a unique combination of fun, skill building, and service. What kind of service are we providing during field day? A lot of people don't think about it, but service was actually in the original intent of field day. It's meant to be an educational and service-oriented event, not just a fun barbecue. It turned out to be so fun, but that's how we all think of it. But there's actually a practical purpose to field day. So it was first held in 1933. Bob was there outwarding everyone else. And 1933, they started field day, and it has grown since then. But it was originally aimed to test field deployable communications. In 1933, how portable was amateur radio equipment? Yeah, not very portable at all. So this was really experimental at the time. But how do we get our equipment out of the shack and out somewhere else and use it? I mean, that never has to happen, right? We never have to set up a station anywhere else to use it. Especially not during a disaster, right? So yeah, this was really to start that. It became a yearly tradition and only took one loss, and that was for Conelrad. Does everybody know Conelrad? The Conelrad was a civil defense initiative in World War II, the control of electromagnetic radiation. So we couldn't have transmitters all over the place because the enemy used that in World War II. So we had signals that got sent out to automatically shut down broadcasters, to shut down your amateur rigs and stuff like that. Because of that, they didn't do field day during World War II. But every year before and every year after, we've had field day. Even during COVID. Remember, we did field days where we didn't leave our houses. Sort of a fun thing. It was different, say that. I think I like it better when we can get together and have a barbecue. But it is the single most popular on-air event of any type worldwide. So ARRL, American Radio Relay League. But it's grown beyond that. This is happening worldwide. How many of us have been to a field day and made an international contact? I know a bunch of us have with our field days. So people get into it worldwide. It's a major event. Fourth weekend in June, and it's about emergency communications training, technical demonstration, public outreach, contest style operating. But here's the great one: the community, the camaraderie.
How many times have we met other operators for the first time ever in person at field day? I know that's happened to me quite a few times. People I may have talked to on the repeaters or on HS and finally put a face to the name at field day because it draws that many people out. So it's a readiness exercise. It's really what the purpose of this was. So when we talk about needing to be able to prepare, chronic behavior, this is a readiness exercise. We may not see it as that, but really we're setting up a comms tent. We're setting up a comms section as we would for an agency partner if they need us. We're having some good food and some good fun at the same time, but this is really preparedness. And it's the best kind of training. Training that's boring and you gotta trudge through it. That doesn't stick. But when it's masked by a fun barbecue, you pick it up pretty quick. So, and like I said, it mirrors real emergency communications. The field day we did in 2020, I think best imitated the comm section of a major incident, or at least many major incidents I've been in, where we had we essentially had a comm element, communications leader, who was putting together that thing and coordinating it. We had comm teams, communications technician specialists in there. They can filtering happen, the rigs operating, worrying about power. We have designated operators, and we're keeping records, all of it. That's what you do in a command post when you're in the comm section. So it really is good practice for that kind of stuff. And Paul often makes really tasty food. There's good opportunity for the public outreach. You guys might remember, I think it was in 2018, we were set up in the parking lot, and we had Roy's trailer with a tower on it out there with a big cobweb, and we had the sign hanging on it. We got so many people stopping in asking what we were doing, and we actually hooked more than one new amateur operator that way. They got interested, and later on, they went through the class and got licensed. So there's good public outreach to this as well. And then there's partnerships that are possible with, CERT, Red Cross and stuff like that. I get that directly from the ARL's talking points. I don't actually know how we would facilitate that, but, bring it. Let's hear some ideas. Because the more outreach we can do, the better we can serve the community as amateur radio operators. So I think that's actually my last slide.
I can address that real quick.
Yeah.
So actually, we do that interface through a couple of different mechanisms. One is the Voluntary Organizations Active in Disaster, and the other is the Citizens Corps Council. So those are two bodies where groups meet together, and Citizens Corps Council, for example, includes VOAD. BIARC is a member of VOAD, so I can represent both BIARC and the Amateur Radio Emergency Service at those Citizens Corps meetings through our VOAD membership. So every year we pay dues to VOAD, $25, along with a lot of other groups like Team Rubicon and Red Cross and Catholic Charities and lots of faith-based groups. They all participate in VOAD. VOAD has a voice at Citizens Corps Council, but Citizens Corps Council is more than just the nonprofits. It's also the government side. And so that would include civil defense, fire can have a seat at the table, lots of different, I think, roads departments in there, the research office, all kinds of different offices or agencies on the government side is at those Citizens Corps meetings. And so that's how we can talk it through and start to think about the whole community response during an emergency. Because the government side, especially, the county side they're really in charge. They're the ones that have been tasked by the mayor with the authority. The Civil Defense Agency typically has the delegated authority of the mayor. And so all of the nonprofit groups, if they want to, make a positive difference, they need to coordinate with civil defense, not go out on their own. but work through things in coordination with civil defense as they've been asked to do. And very often, if they're not going to be doing that, they're not going to be allowed to really participate in the response directly. So that is a very important bridge. Is the VOAD and the Community Court Council are interfaced with government to, especially through civil defense. And Bill Hanson, again, he's an administrative staff officer, right? That's your title? Right, with civil defense. And very glad to have him in. Thank you.
So there's another component about field day that I often forget, and that's, it's kind of a contest, right? There's points. But really the purpose behind that isn't to see who can win field day. I mean, we know that we can win field day, at least locally, right? But their points is awarded on metrics like what kind of power source are you using? Are you using grid power? Are you using e-power? Or are you using natural power like solar or wind or something like that? So that changes your points classification. The number of radios that you need changes your points classification. So it's more about being able to challenge yourself to get into the higher points classifications than just trying to make as many contacts as you can, like a lot of the other contests are. Because again, this is more about testing yourself to see what you can do, testing us as a group to see what we can do, than it is about can we make more contacts than another. I think.
Okay, so that's it for, sort of the background on field day. The
next item to talk about is our plans for field day coming up here shortly. So we know why we're going to have field day now, but how are we going to go about it? Joe, you want to talk about the date, the venue, the time, and all that? And if you'll step in front of this camera through here, then I'll be back.
Hello, my name is Joe W. Taylor. Field day will be June 28th, Saturday, set up at 8:30 a.m. To the latest 8 p.m., but probably be earlier than that. We have a box hunt. There'll be pre-known food, and we need people to bring things like, canopy, chairs, and tables, and things of that nature. It's at Wirewood State Park, Reading Pavilion 4, and we go better with food.
Hey, Joe, I want to see how many people understand or know what a fox hunt is. Raise your hand. You've heard of fox hunt. Okay, we've got just about everybody, I think. But the idea is that you have a hidden transmitter somewhere, and you're trying to use your radios to find that transmitter. And so that's the fox, the hidden radio. We call that the fox. And what have you got this year?
Actually, Thomas is making up a box, and I don't really have too many details.
Okay, so Thomas is our president, and he's out sick today. He came here earlier, but he decided it'd be best for him to not infect the rest of us. Yeah, he's basically got a little transmitter box, UHF, I believe.
Yeah.
Yeah, it's a UHF. And the key to finding a signal that's nearby is a directional antenna, and also the ability to attenuate the signal. So you can weaken the signal strength, and then when you orient yourself, you'll be able to hear where it's stronger and where it's weaker. Okay. Thank you.
Okay, so like you just said, we're gonna have a field day. We're gonna have some events like fox hunt, stuff like that. Fox hunting's fun. We're doing a little miniature version when we do it at field day. Fox hunting can be done at a very large scale. We can have a transmitter somewhere on this island and start somewhere very not near it, and then home in on it. And that requires a different set of skills than skills that you're going to need if you want to do our miniature fox hunt at field day. It's like the difference between 18 holes of golf and playing putt me. So you're not going to use your driver out there on putt course. Same thing. You're not going to use your big, say like Doppler setup to be able to find this hidden transmitter that's going to be relatively close to us. Tony mentioned that you're going to want to be able to attenuate because we're going to be dealing with multi-cap reflections. So you want to be able to parse between those reflected signals and what should be the strongest signal, which is the direct signal feed. And we appreciate we bring it down towards the sensitivity threshold of whatever receiver you're using. So you have to be able to attenuate. There's a lot of ways that you can attenuate. You can attenuate by using an attenuate board, like a set of resistors built into a device, and it burns up a lot of that energy and breaks the signal level down. But there's other ways to do it, like if you've got a 2-meter box, you can use the 70-centimeter antenna that you might have and look for its harmonic, its third harmonic, which is going to be at a much lower level. And that can be a lot more precise than looking for it directly. So there's a lot of ways that you can go about it. Another way that you can do this is using phase meters. And you can use something interferometer. A very easy way to do that is to have something that we call a double duct. It's got 2 antennas that are spaced further apart. And when they're both broadside to the source, they receive the antenna or receive the signal by each antenna at the exact same time. But let's say the bob over there is the source and I'm facing him, I receive it at the same time, but as I start to turn, one antenna receives the signal before the other. And we can detect that with some pretty simple circuitry. So then you can know when you're facing, and you can also go exactly 90 degrees to that, and the interference between the signals will be as key. So you've got 2 ways to try to pin down where that is. There's a lot more on box hunting in the recording of the previous program we did, I think 18 or so months ago. Actually, no, maybe even been longer ago than that. I think we were at the meeting room up at the Payout Community Center. And Les brought in his Doppler and stuff like that. But there is a program out there, I believe we have recorded on fox hunting. If you've never done fox hunting before, I highly recommend that you try it out. It's a lot easier to learn at this small scale than it is if you get up to the big scale when we're using clean tricks like a highly directional or constrained antenna to shoot the beam across the saddle and you're looking at a reflection, not the actual transmit, stuff like that. So this is the putt golf of fox hunts. It should be real fun. We've had a lot of fun with it before. Other things we might have to keep going on. Joe, did you cover the GOTA?
No.
Okay, so we've got a GOTA station we typically put up. Hit on the air station. That's going to allow people to come in and operate under our privileges, unlicensed individuals, and make their first transmission over the air. So the GOTA station is number one, a points enhancer for us, and it's a great thing when people see us out in the venue. We go, what are you guys doing? We can actually sit them down and get them transit. We can also have people with, say, a technician class license sit down on the HF rig and start making HF contacts, mainland or hand or something like that. So if you've got a technician class license or a general and you've never done it, this is a great way to do it. You say, hey, I'm a technician, how can I do that? It's because you're operating under my license permissions as a club trustee. I'm an amateur extra. The call sign is an amateur extra. As long as there's an amateur extra supervising, you are allowed to do that because we're going to be operating under the club's call, KH6DJ. So if you'd like to try your hand making some sideband contacts, this is a great way to do it. We may end up running some digital, either at the same time or separate. We're going to talk about how you can operate 2 HF rigs at the same time here in the program shortly. In the past, Hank, you'd set up, you need to buy a separate transmitter, or did you do that this year, or do you okay,
Planning on it. I had asked, I had set up 10 meters of just handstick dipoles. And first we get that with my dipole beam. And I was making contacts in Japan that way for a while, and then North America that way for a while, just by twisting the dipoles on 10 meters when I was open.
Well, another thing that that you might be able to speak to. There is points given for, and therefore encouragement for satellite contacts on Oscar for the ISS. You've done that on field days in the past.
I have, 2022, I contacted the International Space Station. And in fact, I wound up on their publicity photo for the, for the field day. The space station commander was making contacts. They had a little EWRL flag. And that happened on field day, and I knew I had made a contact with him. So I went to the photo archives, got the download of the original photo, and I found from the EXIF data that photo was made at the exact time that I was talking to him. So I blew up the photo, got a picture of his notepad, and there's my call sign on his notepad in the ISS. That's on my QRZ page, if you folks want to see it. Yeah, that was a thrill of a lifetime. Getting a contact with the space station. I've done that exactly twice. I did it back in 2000, 2001 on the second expedition to the space station when I was back in Oahu. And we did it with just a handheld arrow antenna. Talk to Susan Helms on the space station too. It's great. It's good fun. And there are amateur satellites that come over all the time too that you can check with what the passes are and what the frequencies are and make contacts. I've done that also.
Including a repute on the International Space Station.
Yes, yes. If they're not actively talking, the space station is across the feed. So between VHF and UHF up and down like the piece of that like that. Yeah, outer space is out there.
So if you've never made or tried to make satellite contact before, satellite operations is kind of interesting. Because of the speed difference of a lower satellite and the fixed position on Earth, you actually have to deal with Doppler shift. The frequency is higher as it's approaching you and lower as it's going away. So you have to compensate for that, but it doesn't mean you can't just do it with your handheld. I believe Paul, right here, WH7VR, I believe I saw in your radio, like maybe in your mobile, that you have approaching and departing frequencies. So it was a rather granular adjustment, but you could still go to something in the middle of the approach range and then click right onto the frequency and then click to it departing and increase the time of flight in which you're able to make contact. So if that kind of stuff is new to you, field day is a great way to get exposed to it. I have not checked yet what the declaring elements for any of the satellites are. That's on track, the orbits, to know what birds are going to be available to us during the field day. But there's always at least top. So satellite contacts as well.
The first satellite contact you make on field day is good for 100 points. After that, it's only one each. But yeah, you get one satellite contact that's worth 100 other contacts.
It's worth it. It's just for the fun. I love working satellites. I'm still on a quest to be able to use the repeater on the ISS to be able to make a contact in California from Hawaii because it's a very slim window to do it. We're not going to be able to do that during field day because that requires my polar mount, my azimuth polar mount. But fun stuff. Any other events that we typically do at field day that we haven't talked about?
One thing about the International Space Station, it's really important to know when the passes are going to happen. And if you just search Google International Space Station amateur radio, you'll get to a page where it shows the frequencies. So the voice uplink is 144.49 and the downlink is on UHF, right? It's I think it's 437.8. But yeah, if you just search International Space Station amateur radio.
And I'm drawing a blank for the organization that coordinates amateur satellites. But if you,
AMSAT.
AMSAT, yeah. So if you go to AMSAT, you can actually, where we talk about looking at the passes, you can actually look at each satellite and see what the passes are. And you can plan out weeks or months into the future. Go ahead, Gary.
There's 3 passes that day. The first one was around 9 o'clock. I think it's the Walking 3 passes. Not that interesting. Second one was about an hour later, and that's prime field day pass. So I think that was about a 27 to 30 pass. The other one, 11 o'clock at night. For California thing.
Yeah.
And that's the 74 pass. So that's plenty of elevation. Using the standard diamond that you lose a little bit above you, but your side view still pick it up early.
When we were able to coordinate and work with Sharp and actually make contacts to each other through the Oscar and do it that way. We're going to have somebody local who's also working it, but there's going to be plenty of clubs out there trying to make those.
Rick and I have done that through the space station when they didn't normally have the repeater up, but one time when I was back on Oahu, there was an illuminated pass early in the evening when the sun was on it. We were watching this bright star move over, and I had my radios on. I gave a call just because the repeater was online. Guess who came back? FC is Kona.
Yep.
Yeah, so inter-island even.
Well, it's better to have like a handheld Aero Navi or LPDA or something like that. But I've actually been able to get into that computer and make a contact on a rubber duck.
Yep.
On an HT.
Yep.
So, okay, Cody, did you talk about the food situation or refreshments?
I just asked people to bring in.
Okay, so what is the club bring?
So Thomas is in charge of that. Our president's in charge of
Yeah,
that.
he's not here, so that's why I was asking. Operator, you know, if there's any beverages from the
As far as I know, it's gonna be like, some water, cases of water, ice. We just have stuff like plates, napkins, and things of that nature.
All right, so this is a good message.
Hold on.
Go ahead, Jim.
Are you bringing plates, napkins, and stuff like that, not cooler with ice and water?
But plates and napkins taste terrible. So if you want something on those plates and napkins, remember to bring something. Events like this are as good as we make. Get out of it what you put into it. So remember, bring some food to share, bring some things to share. I mean, within your means, but you know, the more the merrier. Because like I said, we're going to have some ice, we're going to have some plates and napkins and stuff like that. But the actual foodstuffs and beverages, other than drinks and water, that's outside of the means of the club. If you've been to field days in the past and saw the food, the club didn't buy that. Everyone else did. So please come to field day, and it doesn't have to be a ton, but bring something. If you're not sure about what to bring, then reach out to Joe and or Thomas and be like, hey, is anyone else said to bring this? You know, if you want to bring some bread from Honolulu or something, hey, great. You know, but again, you get out of it. Equipment for field day. This is going to be a little bit different this year because we don't need to set up our own easy like we have in the past. We're actually going to be in a venue that has a roof. It's open. It's a gazebo, right?
Pavilion.
Yes, the wedding pavilion, which is, that's what they call it. The building itself is a gazebo style building. So it's open air with a roof. And that's going to make it a little bit easier to get set up. But there's going to be a limited number of seats. So if you got a folding chair, I mean, you may not need it. They may say it's up, but bring a folding chair. And that brings us to the main course of this, which is equipment. So the club is going to be bringing the club's equipment. Because you guys may remember, we pulled together resources. We did silent auction. We put together some money, took some money out of the infrastructure fund, and we bought an FT991A. It's a Yaesu radio that is shack in a box. That's what I call it. It's got the HF. It's got the integrated sound cards for digital modes. It does UHF, it does VHF, so 2 meter size. It does all of that. Plus, the club has a Goda radio, which was donated by one of the members. Not here today. It's lesson or TV. And so those 2 radios be there at a minimum. This year, I believe we're only planning on running one radio, right?
As far as I know, unless somebody else wants to bring one.
So if you want to bring your radio and give it a try, that's not a problem. We just need to do a little bit of coordination to make sure that we're not blowing ears out of each other's radios. So there's no questions about field day this year, about food, the venue, the time, any of that. We'll go ahead and get into the program about how to operate radios in close quarters without blowing each other's ears out.
William,
Yes,
can
sir.
we address digital? Are we doing anything on the digital side at Field Day?
I don't know.
Huh? No? Okay, well, a lot of us have Meshtastic gear, and many of us have Arden Mesh gear. And last year, when I brought my my gear, I was running off an inverter, and the HF people didn't like that. So this
Oh, I
year,
thought the FCC complained about it.
it wasn't that bad. This year, if I'm gonna bring anything, or if anybody is gonna bring anything like Arden Mesh gear, of course, you don't have to worry about Meshtastic, because that's always on batteries. But yeah, it's better to run off DC directly. Leave the inverters at home.
I think Tony bought our smart caps transmitter. And S20 on our field day signal. I just kept one over and turning his laptop off, and I feel bad. But
Yeah, I think the Naval Criminal Intelligence Service or Investigation Service was investigating GPS jamming that day. So there's also the other side of digital. We can do digital sound card modes right from the FT991A. It has the USB port plugged in, and we're going. So if you're like me and the individual guys, I might bring my laptop and plug into that, and we can get on some of the info modes, slow scan TV and ready and stuff like that happen on field.
And there's another place where you can get a lot of points. If we hook up one of our tablets or computers to the 991 and send a WinLink message,
That's right.
we can send it to Alan. He's here on our call. And Alan McBride?
No,
No.
Mitch.
Yeah. And he's our section manager, so I think that's 100 points.
And again, with practice. Go ahead, Jeff.
I just want to say, if we do that, we need to have a Windows computer, because the Chromebook that we have right now for logging doesn't go without too many digital programs.
Yeah.
I've got WinLink on this laptop.
Okay.
I'll bring this in this time.
Okay. Any other questions on the field day? Okay, we'll start with Gary.
quick question on the can like, does it have to be under the club's call? Like, does the club have to set up a link?
I do not believe it has to be on the club's call. WinLink contacts by individual club members participating in the event are counted for the score.
That's
And then somebody over here.
Before you start your program, you want to take a short break?
I can.
Yeah, that sounds like a good idea.
Okay.
We have food?
Well, we're supposed to move that to after the programs, because remember, we're gonna have there's a new format for the meetings that was asked for at the general membership meeting last month, where we don't take a social break in the middle of the program, that we do the announcements, new program, and then we will have, essentially maybe even an hour for socialization after. Because usually what happens is we break in the middle of the program, and then we've got to shut all that down. That socialization is something that most of us actually really look forward to. It's kind of the meeting we originally actually first. So let's take a break, but let's make it a relatively quick one, and then we'll do refreshments and everything. Time trying to put the PowerPoint deck together, so I couldn't put the coexist bumper sticker style text in for the coexist, but that's supposed to be there. This is about how to not clobber each other, and also make it so our radios don't interfere with each other either. So coexisting in close quarters. So we're talking about interference, right? Two radios close together, even if they're not on the same band, are going to interfere with each other. But they can actually do more than just interfere. They can damage each other.
So the sensitive electronics, especially in our solid state, our transistorized receivers, are very prone to strong signals causing damage. We're going to talk about why and how to deal with it. Strategies for multiple radios in close quarters. We're not just talking about field day here. I mean, how many transceivers do each of us have operating in each of our QTHs at any one time? Some of us are more guilty than others, Gary. And there may be specific examples in there. And I'll use myself as an example too, because at any given time, I not only have amateur radio equipment, I've got public safety equipment, I've got professional radio equipment. All this stuff are operating at my house and at the lab 24/7. And that's HF to microwave. And you wouldn't think that microwave could blow out your HF receiver, but it sure can. So we're talking about strategies. We're also going to talk about specific strategies in depth, including filtering and planning. And then real world scenarios, not just field day. And we're talk about some lessons we learned at our field days. So who knows what desensing is? Okay. Anyone want to give us a definition? Oh, all right. Go ahead, Bob.
Definition?
Yeah.
When your sensitivity of the receiver is decreased in somebody else's transmitting, you can still hear them, but not as well.
Yeah. So think about your receiver like a bucket with a hole in the bottom. You pour in a little bit and it never fills up. It goes out the bottom into the rest of the radio. Now, pour in the signal you're receiving, but now pour in a whole bunch from an extra bucket. The thing fills right up. And is the stuff coming out the hole at the bottom the signal you're trying to receive? Or is it all taken up by the stuff out of that other bucket? That's how you can think about desensing. So desensing is an interference thing, but we also have damage that can occur. So desensitized receivers can't hear anything. Damaged receivers can't hear anything ever again. Now, if you damage a receiver, that's a little bit of a misnomer. It may still hear stuff, but not as well. Who here was into rock and roll when they were younger? Yeah. Yeah, exactly. So you may have damaged your hearing, but you can still hear. You can especially hear guys like me and Roy with the pipes. You might not be able to hear David, who's very soft-spoken. Same thing will happen to your radio. You blow out the ears. Yeah, you might still think it's working. It's just not working very good. And it takes, pretty skilled repair, I'll put it that way, to replace the front end components in a radio. It's worse than trying to replace blown out finals in your amplifier stage or something like that, because they're sensitive. They're static sensitive. They're teeny compared to the transistors that are used to amplify that transmit. The MOSFET at your receiver front end might be a tiny little surface mount device, whereas the pills of your final are huge and your big bulky fingers work with them. But we also end up with distorted audio, hash, birdies. And I'm not just talking about the birdies your radio's hearing. I'm talking about the intermodulation that's happening in its transmitter, which is now making noise for everybody else. That's where some of these birdies come from. And then uncommanded TX behavior. Who here does stuff like FT8 and stuff like that with a laptop or WinLink and has ever had your radio key up and then now you can't control your radio anymore? It goes into a runaway because that RF might be leaking into the USB control circuit or the analog control circuit. And now you're not being able to digitally command and control your radio. That's a really common thing. That also happens with a nearby radio. It doesn't have to be the one you're transmitting with. You could end up keying up your HF rig or your 2-meter rig, and your HF rig or 2-meter or whatever other rig that's just sitting there suddenly keys up on its own, uncommanded. That's bad from a legal standpoint, from a technical standpoint. We don't want that. We have to control more than just the interference between the transmitters and a receiver, but also transmitter and other portions of the system. So a field day is intense, multiple stations, fence, and antennas. Who here's been to a field day other than BIARCs? Yep, who here's been to a really big field day? How many transmitters did they have? And how close were they? Right? I mean, you're essentially walking inside of a microwave oven in the near field of all these things. And that's not harmful for you. It's non-ionizing radiation. We all know that. But it can be harmful for these other devices. So Field Day is a great example for this, and we have successfully operated multiple radios at Field Day for Bayer. I don't think we've ever done more than 3 at a time. That's the 270 centimeter GOTA and 2 HF rigs operating on different bands at the same time. But at home, we actually do this a lot, Gary. And so we've got other places where this happens. Contest stations is really popular. De-expeditions, oftentimes they want to be on multiple bands or even the same band at the same time so they can maximize the return on investment for the de-expedition with as many contacts to those of us who want it as they can. So they want to operate multiple rigs, sometimes from a single antenna, because they can only take what they can take. Repeater sites, you may not think about this. This is something that in the professional side, but also in the amateur radio side, we have to deal with all the time. There's a lot of RF at a site. We know that on the Kalani repeater. It is constantly plagued by the rogue signals of the intermodulation that occurs at the Kalani site. There's 2 towers very close to each other. One of those towers has a very powerful pair of FM broadcast transmitters on it. That's a lot of energy to contend with. And that can cause what we call the rusty bolt effect, if you guys have heard about that. So we have to try to filter that out, at least in the out-of-band portions, as much as we can. And we sometimes have to deal with in-band signals too, that popcorn that we get periodically. So repeater sites is a huge place where this happens. But emergency response scenarios, this is something that the EOCs and the mobile command posts and stuff have to deal with, just as we would if we're going out for a POTA event where we're going to have multiple radios. It's the same kind of problem. So, but here's the big one. 2 or more radio home stations. Who here has both an HF and a 2-meter rig? Right? An awful lot of us. Who here has more radios than just those 2? And receivers and SDRs for your pan adapter and on and on and on. Single operated 2 radios. Who's ever done SO2R? It's not something I've seen a lot of the club members do, but I know some operators outside of the club who do this a fair amount, especially in contesting. You can have 2 HF rigs running at the same time, no problem. You can run 2 HF rigs on the exact same band at the exact same time if you do the engineering right. You can do it where they alternate transmit and receive, and you can even do it where they both work at the exact same time. So then we also have, and like I said, I'm going to use Gary, who ran away because he knew I was going to do it. Gary is monitoring 2 meters, 70 centimeters. He's listening to the county P25 on the scanner. He's monitoring ADSB, the aircraft data, AIS, the ship data. On top of that, he's got a WinLink station, and it's got the HF side and I believe 70 centimeter side on his. And meanwhile, he's talking to us on the repeater, and who knows what else is up there. Has Gary ever mentioned he has a very high noise floor? It's actually not caused by this, but it's something else that you have to take in consideration. And the proper techniques for controlling this can help with that noise floor issue. So here's the one we all think of. Strong transmitting signals leak into a receiver. You can have 2 separate antennas and even have a distance apart, and that transmit antenna is going to couple energy into that receive antenna, and we get it into the receiver. Your 2-meter rig doesn't do this because it has a relay inside that switches the receiver out of the circuit when it switches the transmitter into the circuit onto the antenna. It isolates it, and it also usually powers it down. And it happens very quick. There's a relay in there called the TX-RX relay. Well, we can do the same thing externally. But this causes that overload, intermodulation distortion, or IMD. If you look up at the spec sheet of your radio, you might see an IMD figure. And that says if external energy comes into my radio and starts to cause mixing, heterodyning, and we get intermodulation products out of that, how is it going to handle the distortion that causes? In very high-end radios, it handles it very well. In more affordable radios, it may not handle it so well. You may have to handle that outside of the radio itself. But shared grounds and power supplies. Who here has a 2-meter and HF rig on the same power supply? Do you use them both at the exact same time? I have. I've had them both transmitting at the exact same time because I've been talking on the repeater and working FT8 on my laptop. So that can actually cause noise and spurious emissions when you're transmitting at the same time. But worse, you can actually get noise from one radio that makes it into the receiver of the other radio through the power supply because the receiver takes power. So if that power supply is no longer able to keep up with the sudden pulses, say you're doing DMR, something that's TDMA, works pulsed, that can cause this pulsing to happen that doesn't get smoothed out through your HF rig, and suddenly your AGC on your receiver goes bonkers and you can't hear anything. So being able to control it even at the power supply level helps. Splitting power supplies, having a nice ballast on there. What would we use as a ballast on a power supply? Big capacitor, a battery, something like that, that gives some sort of inertia where you're not going to be trying to deal with a voltage regulator. You're going to be dealing with a more steady source, like what's coming out of that capacitor to smooth that out.
10 pounds of iron.
There you go. And then we also end up with problems with like audio coupling and RF feedback. That's something we deal with all the time here with our meetings, where we're dealing with audio coupling and feedback. We can only run one set of microphones and speakers at one time, and they have to be in the same device. So like right now, my audio is going through my iPhone right here, and I'm listening to the people online through it so that we don't get feedback, but they can actually hear me better. And that's where, like Tony was talking about, here in the room, we have to worry about that. We haven't even added RF into it yet, but that same concern can also come up when you're operating multiple rigs together, especially when the audio is both going through a single device, like a computer or something like that. The more pound-free you are, the more closer the antennas are together, the worse it is. Remember, inverse square law. Double the distance is a quarter of the power. Well, it goes the other way too. So the closer it gets, the coupling is so much more stronger. And when you finally get within the near field, so when you're actually within the magnetic field or the electric field of the antenna with the other antenna, it's essentially direct coupling. It might as well be connected with a piece of coax. So we need to be able to break that. And there's techniques for that. So even with filtering, we know what filtering is. We've got multiple types of filtering. So even with filtering, a transmitter near you can still cause damage to your receiver. Transmitters aren't clean, despite what the manufacturer's data sheet says. There can be little spurs, harmonics, and stuff that come off. And if your HF rig is transmitting and you've got your 2-meter rig right there, and one of the spurs happens to land on the frequency it's receiving on, it doesn't know that it's a spur. It just knows it's RF energy. And it can be so close, like I said, it's within the near field of that HF antenna. It might as well be connected by a piece of coax, and you can burn a little hole in the gate of the MOSFET that is your receiver front end. Go ahead, Joe.
And any of the things that you talk about, like the damaged receivers, can they also damage like your cell phone or mesh testing device or things that are close by on you?
So the question for the people online was, these spurs and signals and stuff that damage your receivers, can they also damage the receivers in your devices that are near you, like a cell phone or your Wi-Fi device or your Meshtastic, right?
Yeah.
Yes, they absolutely can. However, there is significantly more engineering in the receiver front end filtering and protection in your cell phone than there is in any of our HF or 2-meter rigs. The other thing that helps is that most of those are way up in upper UHF to lower microwave. And we're talking about HF and VHF, which means that the capture area that they have is not huge. They can't grab a lot of that power even in the near field. So they have receiver protection, good filtering, and little antenna. And that helps. You guys know that antenna perform resonance really only matters On transmit, you can receive very well on a non-resonant antenna. You can try it sometime. Try receiving an AM broadcast signal on a 2-meter antenna. You can do it. That's a tiny antenna for it. But you try transmitting an AM MF signal on that antenna, and it's not going to work. So that's a problem with this, where we've got a transmitter next to an antenna. Even though it's non-resonant, it can still pick up the energy just fine. And that matters with like your HF antenna and your 2-meter antenna, because it essentially becomes a high gain 2-meter antenna, because it's a, let's say, a 33 wavelength long. And there's a lot of quarter wave resonators in there. And those voltages can stack, and you can blow out a receiver that way. It's easy to solve with a simple high pass or a low pass filter on the HF rig. And most of them have a brute force filter on the receive just to get rid of those upper frequencies. And that can bring those down sharply. I forgot the name of the brand. What's the uber cheap HF rig that's pretty common at the moment?
Okay.
No, HF.
Oh,
It's the Baofeng of HF rigs.
Zygu?
Yeah, Zygu. So the early Zygus had no filtering, and they were very prone to this damage from 2-meter receivers. The ones now, I understand, have a basic low-pass filter in the front end, and you have to have it, and that's why. When you're going the other way, a basic high-pass filter helps an awful lot. But if you have spurs that are in band that came from lower or above, it's still an issue. So we need to use receiver protection devices. Good transceivers have a receiver protection device built in. This can be done with what we call pin diodes. So if you guys don't know what the different flavors of diodes are, we can have a different talk about that. But pin diodes are ultra fast switching diodes suitable for RF work. And if you put them back to back, you don't cross the forward threshold of them to make them conduct with normal RF signals. But if a strong signal comes in, the peaks are high enough, they start to conduct and they become a dead short. And that causes an impedance mismatch, and the signal gets reflected back out. There's other devices that work in a similar way, like a gas discharge tube, clamp diode, RF crowbar circuits work this exact same way. But then we have saturating transformers. Saturating transformers is another really popular way to do this. You use something that has a terrible core for the frequency that you're operating in. And you wind a horrible transmitter. It should perform awful. But at the tiny signal levels that we have, it passes across the transformer just fine at these low levels. But if you try to put any power through it, the core saturates, you get a massive impedance mismatch, and it reflects it away. And what's critical about all of this? It's an on-off switch. You can't listen through it at that point. So these are protection devices. They're not techniques for actually operating in close quarters. But you need both. You need the fail-safe to protect your electronics, and you need a way to handle the additional energy. None of these are linear devices. Linear devices are things like resistors. Doesn't matter what frequency goes into it, what amplitude goes into it, the effect is the same. So resistors are resistors at the same impedance, the same opposition to current flow, no matter the voltage they're in, until you overvolt it and it arcs, or you put too much through it and it burns. So it's not going to be able to use what we call non-linearities to mix signals together to cause that intermodulation. None of these are that way. So when they do work, they turn into noise sources, broadband noise sources. So that's another reason we don't want to rely on these. Receiver protection is also critical for things you wouldn't think of. SDRs, yeah, we'd probably think about that. That's a receiver, right? What about a preamplifier? Is a preamplifier any different than a receiver front end? No, it's a receiver front end and then a little transmitter that goes into your radio. We need to protect that receiver front end too. We can protect it using the same techniques. And if we don't protect it, it's going to suffer the same damage. It's going to go deaf. Receive only antennas, you got to treat them like any other antenna. You can transmit through a filter, and that's not going to affect things outside of your band if you're using a nice band pass filter. But if you don't also put a filter on the receive antenna, if you're using a separate receive antenna,
it is not immune from all the other transmitters around you. So you got to remember both sides of the circuit. That matters a lot in repeaters because they've got two separate radios in them, the transmit radio and the receive antenna or receive radio. So we have a separate receive antenna. But other rigs you might have, like your HF rigs, may have a separate dedicated receive antenna port. Does anyone operate with a separate receive antenna in here, at least periodically? Yeah, I think I'm the only one. Okay, a couple others. Yep, it can be a really powerful way to handle things, especially if you want to use a receive antenna that is deaf as a rock, because it's really good at busting the noise.
Loop on the ground.
Yeah, loop on ground is a great example of that. It's a horribly inefficient antenna, which is great for receive antennas because that means all the nearby noise sources are dead and you're picking that signal out. You're trying to shift the entire signal to noise ratio down. But when you do that, you need to protect that thing, especially if it's an active antenna. That means it has a low noise amplifier in it. That low noise amplifier is still operating when you're transmitting. So you might need to protect it from your own transmitter in the same radio. If that transmit relay in there doesn't work on those external devices. So you may need to cut the power to it or filter, give it a receiver protection device. So you might say that timing is the easiest way to do this. Don't transmit on the same band as somebody else is receiving at field day, right? It's going to help you not interfere with each other. If you guys have ever tried to herd those cats before, you know, even though this is the easiest way to accomplish this, this is the hardest way to accomplish it, especially when somebody else shows up to the same park and has field day in the same park with you and they're not a part of our group. And that's happened in many field days in the past.
Even when I was operating on 10 meters only, I told everybody this is gonna.
Yep.
Somebody still tries to go on 10 meters on the other radio. Ooh.
Yep. So timing helps a lot. And you can build timing into your station at home. You can do it manually. You could say, you know, when I transmit, I'm going to use one antenna and I'm going to switch and use a receive antenna. I just happen to have this here because somebody gave it to me to deliver to another operator. This is an antenna switch. You could do it manually. Transmit, click, receive. Click back, transmit, and click, receive. That's not very convenient, right? Well, you can actually, on most rigs, take a contact closure out of the accessory port and drive a relay that does this. I do that at home because I run a PAN adapter on my HF rig, and the PAN adapter is an SDR. It switches the SDR onto the antenna when I'm receiving, but as soon as I transmit, it clicks that relay over and it grounds the SDR receiver so that it doesn't get its ears blown out. That is a form of timing control. It's just automated. Maybe one year we'll set up timing control where the rigs interlock so that only one rig can transmit at a time. So that way there's no accidents. That can be done. You can put relays on each rig. You can also do it in the logic circuitry in some rigs. And then we can avoid overlapping modes. You can do modes in different parts of the band. You can do voice way up high and CW down low. That works. You can do that if you properly filter, if you properly provide these other protection mechanisms. But doing sideband and FT8 at the same time, those are usually pretty close frequency. You might not want to do that. So a little bit of planning. Scheduling usage, you're taking turns. You know, hey, over there, you're going to use 10 meters from these hours. Can we take 10 meters for this hour? Back and forth. You can coordinate like that. And then we call this in the business time division multiplexing. Your cell phone works this way. The County P25 radio system works this way. The DMR radios work this way. There's 2 time slots in a DMR or P25 channel. I use it for 20 milliseconds, then you use it for 20 milliseconds. Then I use it for 20 milliseconds, and you use it for 20 milliseconds. We're in 2 different time slots. We can be right next to each other and never interfere with each other. So what we're talking about is time division multiple access. Band planning, the second easiest filter, but also seemingly pretty hard. This is what we were talking about. Hey guys, I'm only going to be on 10 meters. And then somebody walks in and goes, oh, I want to try some 10 meter contacts. And they switch it over and blow Hank's ears out. Again, very difficult to do in real world. And I'm not just talking about field day. This happens out at Mobile Command Center in public radio, where
an agency comes in and they say, I'm going to operate HF and I'm going to use my HF radio on ALE, automatic link establishment, to get back to my organization on the mainland. But there's another agency there who's also using HF. It might be on different bands, different frequencies, but now they've got a problem. So in ICS, we solve this. Does anybody know how? It's a document called the ICS 205. Before you're going to operate at an incident, you coordinate with the COML. You get yourself on the ICS 205, and we can coordinate who's using what frequencies, who's using what bands. We have to do the same thing for events like Field Day, or if we're going out and assisting an agency partner. We can't just operate. We need to coordinate, not only with them, but with the other amateurs who are supporting them, and also the other amateurs who are just trying to be amateurs. So again, seemingly easy, but also very hard. So filtering. Filtering is hard, a lot harder. But man, is it easier. Because I can filter on my radio and make it so that you over there on another band don't affect me at all. So are all bands able to be filtered from each other equally? No. Who can think of a pair of bands that are very difficult to separate from each other? 40-20, but actually 40 and that is 40 has an integer multiple higher than it. 15 meters and 40 meters are co-resonant on the same antenna. A 40-meter quarter wave antenna is a 3/4 wave on 15 meters. They couple to each other perfectly. Well, the way a lot of our filters work, that means that 15 meters can come right through that filter and get us on 40 meters. So you have to select your filtering accordingly. Are there other bands that are like that where they are integer multiples of each other too? That come to mind, 2 meters and 70 centimeters. So you have to use non-harmonic filtering. So there's a difference between harmonic filtering and non-harmonic filtering. If we do a lumped element filter, capacitors and inductors, that is non-harmonic because it blocks everything above it or everything below it. Or if we put a low pass and a high pass back to back, we only pass what's between them. But if we do it with a resonant stub, that resonant stub is a harmonic filter, which means that it will resonate at 40 and 15. So I can't operate 15 and 40 at the same field day and trust that my 40 stub is going to block out that 40 signal from the 15 because it's also going to block my 15 signal. So intelligent filtering is important. And that's one of the options. We've got band pass filters, notch filters, high pass filters, low pass filters. Or band pass filter is typically a low pass filter and a high pass filter back to back. But then we've got these cheap coaxial stubs. We've used these great. We've used them at several field days. 2018, I made some on the spot. It's the first field day I ever attended with the club, I think. And I made it with junk out of the back of my truck. But then I made some nicer ones for a year after that. And then last field day, I made a set out of a whole bunch of scrapped LDF 4-50A, which is half-inch corrugated coaxial cable, commonly known as Heliax, which is brand name. The stubs cue how tight the filtering can be and how deep they can notch out is directly set by the ohmic resistance in the filter. Because we're passing a signal down it and it's losing signal across the way. It has to reflect and come back up. It's losing more signal. And it's no longer equal in amplitude to the signal we're trying to block. So a little bit of it gets passed. So the better coax you use, the better filter you're going to get. But even with that, coax filters are a brute force thing. They've got a very wide bandwidth. So if you use a coax filter on 18 meters, or 18 meters and try to operate on 15 meters, it's not going to work. They're too close. Even though they're pretty far apart in our minds, they're too close. So you have to use intelligent filtering. And here we're trying to catch that energy before it ever reaches the rig. And this gives us the option of multiplexing. So if you go to DX Engineering, say, just any vendor, and search for a band splitter or a diplexer, it's all going to be stuff that you find for like 2 meters and 70 centimeters. The same exact device, they call it a multiplexer when it's used in HF. And that's actually the term we use in engineering outside of ham radio, even for stuff that's VHF and UHF. It's a multiplexer or a band splitter. You can get a contesting multiplexer that lets you use a single antenna with rigs on every HF band at the same time. You just have to make sure that the antenna can handle the power of all the rigs at the same time, because current is current. And what it does, it sets up a low pass filter and a high pass filter. And then everything above that filter goes, to these high pass ports. Everything below it goes to these ports. And then you tree additional low pass and high pass filters. And you can plug in radios, and everything below a certain threshold, let's say 40 meters and below, goes to the lowest port. And then you get, say, 20 meters to the next port. And you get 15 and 18 through the next port up. And then you get 12 and 10 through the next port up. That's what we call multiplexing. FDMA, frequency division multiplexing. You might know that term if you know P25 and other public safety radio and cellular and stuff like that. FDMA is what we're doing. It's a form of multiplexing. Now, this isn't going to be quite good enough. You're probably going to be able to want to run pass filters on each radio you're using and give yourself additional isolation. But this means we can set up rigs on every band at a field day and have a dedicated rig for each band. We could operate single rigs this way, and we could use, say, like a cobweb and actually get gain and directivity towards the mainland. We can run multiple radios on different bands at the same time. We could run all the radios at once if we wanted. This is something we've never tried. This might be something we want to think about for a future field day or something. One year we tried some band pass filters. Unfortunately, the caps in them had drifted a bit and they were no longer on frequency. Hey, were those yours?
Yeah, they're crap.
Okay. One of them was actually still good, and it worked beautifully because we just put a stub filter on the other rig, and we operated 2 rigs that way, and it worked beautiful. You can use stub filters with these to additionally provide more isolation as you attach more and more radios. Can you do this at home? Who here has a diplexer or a triplexer or a band splitter for 2 meters and 70 centimeters? It's the same thing. You can get them that also separate HF and 6 meters. Well, we consider an HF band, but you may not want to run on the same antenna. So you connect it just to your HF port, which carries HF and 6 meters, and now you split it out and you run a separate 6-meter antenna and an HF antenna for the bands below it. They can be used in either direction. So at home, this is a great way to take care of things because they also provide pretty good filtering. You might have noticed that last year and the year before, we put a diplexer on the GOTA rig and operated it just on 2 meters. We terminated the 70 centimeter side into a load because we're just using it as a filter, a pass filter, and that kept noise from the HF rigs out of it. So these are powerful devices. Who here would love to run something like a hex beam at a field day? Right? Get some actual gain and directionality. It doesn't increase the power of the radio, so we're not changing our rules, but we might actually be able to get into some people we've never been able to work before on the mainland. This is a way we can do that. So physical separation still matters. Like I said, we don't want them to be in the near field. That is very difficult to deal with because the energy levels just get so much higher. If we can get them outside of the near field, that's great. There's other things that can be done though. Use cross polarization. So we know that we have an E field and an H field, an electric field and a magnetic field in our transmitted signal, received signal. The orientation of those determines the polarity. So if the E field is up and down and the H field is side to side, then we are vertically polarized. We describe our polarization based off of the electric field. So if we run one antenna with vertical polarization and the other with horizontal polarization, and they're not in the near field with each other, we can get somewhere between 10 and 30 dB of isolation. That's up to 3 orders of magnitude less signal coming into each antenna from the other one. Now, in real life, that's where I say 10 to 15, because those signals reflect, they get distorted, they come back, but you can get up to 30 in a perfect world. In practice, you can get as low as 10 as long as you're out of the near field. That's free. You just run one horizontal antenna and one vertical antenna, and it's free. So you can do that. And we often do this in other applications where we do what's called slant polarized antenna, because we run one which is slanted one direction 45 degrees and one slanted the other direction at 45 degrees. They've got great isolation from each other. And the person at the end that has a vertical antenna can hear them. There's a dB and a half of loss. The person on their horizontal antenna can hear them with a dB and a half of loss. So it works great no matter what antenna they have on the far end. So that's very preferred for things like 10-meter repeater. You use a cross-polarized antenna. Have you guys seen a cross-polarized Yagi before?
FM broadcast, it's the same way.
Yeah.
Broadcast,
Well, they may be circularly polarized.
well, a lot of them too are just crossed over dipoles like that.
Yep. But when they're crossed over, if you feed one 90 degrees out of phase with the other, it actually makes the fields spin as they leave the antenna, and you're circularly polarized. So if you spin one left and you spin the other one right, it's the same as having one vertical and one horizontal. They don't jive. They don't dance. So another free way to do it. It's better to have terrible performing antennas far apart from each other than the best antennas within the near field of each other. So Gary operates a WinLink station at his house. It's on HF. His lot is only so big. When that thing kicks up, when we're on the HF TechNet, we disappear together because there's no separation available, and its frequency is so close to ours. So that, again, separation is really the way to do this, but we don't always have it. And that's where the other tools come in. And then the separation, put a note down here, that doesn't matter when you're multiplexing, because it's the same antenna. You can't separate the antennas from each other. So you have to use these other methods. Go ahead.
Is there a rule of thumb about how far you should be to pay if, let's say, you have one HF, one VHF, or 2 bands of VHF?
Not exactly a rule of thumb. You can calculate what the isolation between the antennas are. Like I said, the near field just assume that anything within a half a wavelength of the antenna is within the near field. And then within 1 wavelength of the antenna, you've barely dropped anything. So, for instance, with repeater antennas, we often run a transmit antenna at the top and a receiver antenna at the bottom, or vice versa. The old way was to put the receiver at the top and the transmit at the bottom. That's less favored now. And then we used the vertical separation from each other because they're dipoles. It's got a null off of the end of it. And then the distance improved that. The distance to get adequate separation to not need filtering at a 2-meter antenna is 80 feet between those 2 antennas, if you want that isolation. The same thing at 900 megahertz is like 6 feet. So frequency matters a lot. So grounding and isolation, we talked about this. You got to think about more than just the antenna side of things. If you use your common sense grounding, if you follow the best practices and have everything tied to that single ground point and properly grounded, you're not going to have the ground loops the same as if you have floating systems and are relying purely on the grounding in an outlet or something like that. Who here has ever transmitted and taken an RF byte off of the chassis of a radio? Yeah, I've done that plenty of times. Or even my desk does it too, because my desk is glass, but it's got a metal frame. And that metal frame acts like an antenna when I key up my HF rig and the energy couples to it. Well, if I ground that desk to the ground bar, I don't get zapped, and that's great. But if I actually sit my radio on top of it, that energy capacity couples into the chassis of the radio, and my noise floor goes through the roof. So you have to think about more than just the antennas. We have to think about the unintentional antennas. So you can float isolated equipment. Do we know what that means? It means you don't ground it. Does that mean it's ungrounded? Only if you're a fool. So you still have to have a ground in the system somewhere. That ground might be out there at the antenna, and you might be grounding your rig over the feed line and then grounding out at the antenna. And if you do that, it actually creates a current bias, taking the noise away from you, kind of like a beverage antenna. But you don't want to truly ever float your antenna unless you're operating in a completely floating system, such as your car. Is your car a floating ground as you drive down the road? Yeah, it sure is. It has a capacitive coupling to the earth, but it doesn't have DC discharge through the tires to do much at all. So floating is a misnomer, but use chokes to block the RF. So if you're going to ground your rig out to the antenna because you're floating on a DXpedition and the antenna might be out there in the water or something like that, giving you a great ground, you can consider throwing an RF choke, a ferrite, on the coax near the rig to keep any of that reflection from coming back to you, from biting you on there, but also from going across the common power cords into the next rig over. So think more about more than just the antenna, ferrites and everything, your power, your mic, your data, your keyboard, all of that stuff. It all makes noise. And other transmitters can key up your radio by screwing with your keyboard. Done it. And then coax chokes. Move common mode current. So I have a 2-meter antenna at the top of the mast on my roof. It's 35 feet up. So I've got 22 feet to the bottom of the mast and then 35 feet of the mast. That mast is also my HF antenna. So the coax is definitely in the near field for that 2-meter antenna that's on top of it. If I just left that coax as it was, number one, it would bleed off all of my HF signal and my pattern would be terrible and I wouldn't be able to make any contacts. And number two, it would, at the other end, get into the receiver circuit because the jacket is connected to one half of that circuit up at the antenna, and it would blow out the ears of that 2-meter rig. So I've got a choke at the top, right before the antenna, the 2-meter antenna at the top, and I've got a choke at the bottom. So that actually becomes a skeleton antenna for me. You guys know what a skeleton antenna is, right? So that piece of coax that's in the middle, the chokes are set so that it operates on a different band than the vertical does. So the vertical gives me 20, and the band or the piece of coax that's floating gets excited by that antenna, and it actually gives me a good match on, I think it's 15. So I've got 20 and 15 the same way. So yeah, we actually already found that. So tools to help you. Who has a tiny SA, a tiny spectrum analyzer? That's a good way to look at stuff. Plug it into one of your antennas for the other one and see what your filtering and receiver production is actually doing. Are you seeing spurs that are coming in through your filter? Do you need to do something to take care of that? Is your receiver protection clicking? And that's going to be poor performance? Your tiny SA. But who here has an SDR of some type? Those actually make a better spectrum analyzer than most spectrum analyzers. So you can hook up your SDR and monitor that way too. You can actually see as you're receiving what your rig is actually getting with. So if you're like me and you're transmitting on HF and receiving or transmitting on 2 meters, I can move that SDR back and forth between the two antenna systems, and I can see if I'm getting spurs coming in, if I'm getting a high level coming in, if I need to add filtering. It's a fantastic tool for it. Band scopes and pair adapters, if they're built into your radio, are another good way to do that. Most of those actually either work at IF or they work at the audio frequency giving you the IF. So you're only seeing what's behind the IF filter. Not quite as useful, but it can be good. dumbing loads and signal generators. So if you have a high noise floor at your house and you want to see actually what this isolation is doing, you can hook up a dumbing load to the end of that and then put your signal analyzer behind that and see if you're getting noise bleeding in through coax that isn't fully shielded. LMR 400, Hardline, and Helax, that's all fully shielded stuff. A lot of the other coax that we use, only 80% of the signals from around us are kept out of the coax. 20% of that noise can still get in. So that's something you have to worry about. You throw a dumbing load on the end and you're still hearing noise, you've got leakage somewhere. We talked about push-to-talk interlocks, where if you key up one radio, it automatically disconnects the antenna on the other one with a relay. Those are definitely an option. And then antenna relays and sequencers. And that's what we were talking about, where you can make this automated, where your, let's say your WinLink RMS gets deactivated when you are operating HF to be on the TechNet or something along those lines. It's a broader, more granular control with the relays. But sequencers happen at the control level. You can literally tell one radio that the channel is busy by putting in a signal on the busy port in the accessory connector. But you're actually not telling it the channel's busy. You're just injecting that signal from the push-to-talk output on the other radio. So it's an interlock. It won't let the two radios operate at the same time. So last year's field day, we had a couple of bandpass filters that were very coarse. And most of the bandpass filtering that we used was diplexers, where we were splitting out a 6 meter from HF, so we could work them separately. And we had 2 meters outside of that. So those were the bandpass filters, but we had the resonant coax stubs. That is very manual filtering. It's kind of a pain in the butt to get the right mix happening. And they're big and bulky and stuff like that. I think that's what we're going to be using if we choose to use multiple rigs coming up on field day, is this manual approach. But in the future, maybe we want to try. Stations were too close together and we didn't have cross polarization isolation. What was the limiting factor? It was the size of the part, the size of the venue. Things could only be so far away. And we had a vertical antenna and a vertical antenna at the same time for some of that operation. It wasn't intentional because we'd actually had a horizontal end set up for most of the time. But at some point, somebody wanted to try the club's antenna, which is a vertical, and they set it up and they tuned it up to 10 meters and coupled right into his 10-meter vertical antenna. So we need to make sure that we have cross-polarization and that those antennas aren't too close together. I said stations here. I should have said antennas. We can put both stations in the same tent and have the antennas separated very far. That works fine. Core band planning. Well, we tried. Hey, said, hey, I'm going to be to in 10 meters. We didn't put like a sticky note or something on the radio that said, don't use 10 meters at the other tent. So could have done better there. Overlapping band use time zero for that, and we had no shared antenna attempt. If we had something like the Cobweb that we used in 2018, that's a multi-band antenna. We could use some band splitting, and we could operate 2 rigs on the same antenna. We could do it with a hex beam. We could do it with whatever else we wanted to use. That's something for the future. So my home shack is a mess. You guys know that a mechanic's car is often the one with the most stuff broken on it. They know just exactly what they have to fix and they don't have to fix. So I'm a busy guy, and I know what I can get away with. So my shack does not always look the best. I still haven't put in the new building penetration. So I'm still running all my cables in through one of the windows with the corner of the screen, pried out a little bit. Everything's grounded, and it's grounded well outside. And unfortunately, no. But I'm in there at any given time, I might be running 6 receivers and 2 transmitters. And that's before I start playing with him. So it takes a lot of discipline. I've got antenna relays set up. Those relays are controlled by the rig they're on, like I said, to switch between my SDR and the antenna so I can use it as a waterfall, as a fan adapter, but also for monitoring interference and noise. But then I've got a couple of interlocks that are set up to where if I transmit on my public safety HF radio, it actually switches off and connects my HF antenna from my amateur side to ground to keep it protected. I usually disconnect them, but I'm not perfect. I'll forget. That kind of control isn't exactly cheap unless you can find good deals on surplus relays. But all the rest of the tools that are available, I'm still using them. Go ahead.
After losing $1,000 satellite with the lightning bolt, I got those relays and I got them on my UHF and VHF antenna feeds. And when I shut down the system, those relays disconnect the antennas and the radios are put in the dubbing limits.
Mhm.
It wasn't cheap, but it was a lot cheaper than another $1,000 rig.
So, and then I've got this terrible thing where I switch antennas between radios constantly. And I've always meant to put together a nice patch panel where I've got a bunch of BNC connections up here that go to each individual antenna, and then a bunch of BNC connections down here that go to and like filtering elements and stuff like that. And then a bunch of more BNC connections down here that go out to all the antennas. I've never had the time to get them. So, you know what? The rest of it. First one. I have everything real well. So, up here, even do it on the same antenna, it says. Time to get free. They're cheap. That's easier to do in your shack than it is at a public event. We can do better with our game at the public events. Maybe a little sticky note saying, don't use this fan, something like that. Filtering and spacing make a big difference. Receiver protection matters. You can get a cheap receiver protection circuit to put in line off of eBay. At least they used to be cheap. I don't know if they still are. I think I paid $1 something for one for my SDR. And again, that's there in case I mess up. If I forget to disconnect or I don't connect the relay or something, it's going to protect the device. And playing is cheap. Defense isn't. Damage is expensive. So that's all I have today. Sorry I didn't have any good hands-on stuff or pictures. I just flat ran out of time because there was only 3 weeks between this meeting and the previous meeting, whereas usually we have 4. So just out of time. So I hope I didn't put everyone to sleep too bad. Before we take questions, I'm going to switch back to the other audio. So we can see if there's any questions. All right, before we adjourn to the cocktail party, is there anybody online that has a question about anything, whether it's about multiple rigs operating at the same time or anything else? Field day questions or anything? Okay, I ain't getting anybody in the room with any questions. Go ahead, Jeff.
I just want to find out a show of hands, who actually thinks definitely be a field day?
Who's coming to field day?
Thank you.
All right, any other questions?
Yeah, is anyone planning to bring a rig? Except rig?
Well, I know the club's going to bring the rig, and I might bring the club's other rig that's in for repair. Anybody else want to bring a rig to field day to try out?
one maybe you haven't used or what you want to show off?
Can we get confirmation on who has the rig, which batteries you get? I seen some stuff going around, so I wasn't sure the details.
Roy has the rig last I heard, is that correct?
No. So Thomas has the rig, Thomas has the antenna, is the computer. I believe Ori has the
Roy's the
battery.
battery.
Ori has the battery, and we're gonna connect to Thomas to get that and make sure it's all working.
What antenna does he have? You said
I
the
believe,
antenna.
Did you give him the, HS antenna? HS.
Does anybody want to bring an antenna to try out?
I'll bring the antenna Roy made for me.
Okay,
That's going to do better than the ATAS.
well, this is a good chance. If you've got an antenna that you wonder if it's any good or not, you tried it at your QTH and you're just not sure if it's up to snuff, bring it to field day. We'll hook it up to the rig. We'll see how it performs there.
Too bad DLK he's the antenna man that loves to do it fairly.
Mhm. All right, well, that's all I have. So we go ahead and have our social session. All that. Thank you for your attendance.
Thank you.